Hi and Assalamualaikum everyone. So my name is Umar Al-Hadi bin Syari Anwar, and I'll be presenting about behavioral design pattern and observer pattern. Okay, so let's start with the definition of observer pattern. So the observer pattern is a behavioral design pattern that defines a one-to-many dependency between objects. In this pattern, an object known as the subject maintains a list of its dependency called observer and notifies them of any state changes, usually by calling one of their method. It is mainly used to implement distributed event handling systems. Okay, so let's move on to the intent. So observer is a behavioral design pattern that lets you define a subscription mechanism to notify multiple objects about any events that happen to the object they're observing. Next, the applicability. So suitable for scenarios where an object needs to notify multiple other objects about a state change without being tightly coupled to them. So the example is including something like event handling system and real-time notification. So next is the structure, which the publisher, the object that maintains a list of subscribers and notifies them of state change. And for the subscriber, the object that registers with the publisher to receive updates when the publisher state changes. And finally, for the participants, so the concrete publisher will implement the publisher interface and keep track of the subscriber. Meanwhile, the concrete subscriber, they will implement the subscriber interface and update itself when notified with the publisher. And the customer and store scenario where publisher will store which tracks product availability, and subscriber the customer interest in the particular product, such as new iPhone model. Okay, so next let's move on to advantages. So first of all, loose coupling. So the observer pattern promotes loose coupling between the subject and observer. The subject does not need to know the detail of its observer, which makes the system more modular and easier to maintain. Next is the dynamic relationship. Observer can be added or removed dynamically at runtime. This flexibility allows the system to adapt to changes in the number of observers without modifying the subject. Okay, and then consistency. So the pattern ensures that all registered observers are updated automatically when the subject changes, which help maintain consistency across the system. And then moving on to the disadvantage. So first of all is performance overhead. So if there are many observers, updating all of them can introduce performance overhead, particularly in the notification process is complex or observer perform heavy computations. So, and then is the unintended updates, which in case where observers are not properly managed, they might not receive notification they are not interested in, which can lead to unnecessary processing. And then dependency management. While the observer pattern reduces coupling between subject and observers, it introduces dependencies between observer and the subject. If not managed carefully, this can be led to a complex web of dependencies that can be hard to track and maintain. And then moving on to the real world example. So the first of all is event handling system, where GUI can change, where changes in UI element triggers update in the other components, and model view controller architecture, where the view observers of the model updates itself when the model changes. Okay, so for the scenario, imagine a weather station that monitors various weather conditions, including temperature. So multiple devices and applications need to be updated in real time whenever the temperature changes. So this scenario is perfect for applying the observer pattern. Okay, so first of all, the weather station class acts as the subject, which is the observable. So it maintains the list of observers and notifies them when the temperature changes. Second, the observer interface declares the update method that concrete observer must implement. Next, the temperature display and weather app are the concrete observers. They implement the observer interface and define how they react to the temperature updates. And next is when the weather station temperature changes, it automatically notifies all registered observers. And finally, each observer then updates its view with the new temperature. Then this pattern allows for a one-to-many dependency between objects, where multiple observers are interested in the state of a subject object. When the subject's state change, all its dependent observers are notified and updated automatically. So the observer pattern is beneficial in this scenario because it promotes loose coupling between the weather station and its display app. New types of display or app can be added without modifying the weather station class. And finally, the observers can be added or removed dynamically at runtime. For the requirement for the scenario, first of all is the real-time temperature updates, support for multiple displays, ability to add or remove display dynamically, minimal coupling between weather station and display, and finally scalability to add new weather metrics in the future. And then moving on to user needs, so the access to the current temperature, customized display option, consistent information across all device applications, quick response time for updates, and finally ability to choose which update they receive. Okay, so let's move on to the UML diagram. So from this class diagram, you can see the subject represents the core abstraction, and the observer represents the variable abstraction. The subject prompts the observer object to do their thing. Each observer can call back to the subject as needed. Moving on to the evaluation, so let's talk about the scalability and performance. So first of all, it is easy for accommodating new observer without modifying the subject, and then it is efficient for a system with a moderate number of observers. Next is the maintainability and flexibility. So first of all, it promotes loose coupling between subject and observer, allow for easy addition or removal of observer at runtime, and follows the open clause principle, enhancing extensibility. And finally, reusability and modularity. So first of all, it enables and reuse both subject and observer component independently, and enhances modularity by separating core functionality from dependent component, and finally facilitate the creation of generic reusable observer interfaces. Okay, so finally let's talk about the alternatives. So first of all is the event-driven architecture. The reason why is because it is flexible. Event-driven architecture allows more dynamic and flexible system behavior. The components can react to event without needing to be directly linked to the event source, enabling easier addition of new functionalities. Second is the scalability, because this architecture is highly scalable and can handle complex scenarios with multiple event procedures and consumers. It's particularly well suited for distributed system and microservice architectures. And then let's move on to the comment pattern. So the comment pattern is the second alternative because it can decouple through encapsulation. So the comment pattern encapsulates a request as an object, allowing the parameterization of client with different requests. So this can be used to achieve similar decoupling as the observer pattern, but with more control over how actions are executed. And finally, because it can undo functionality, unlike the observer pattern, the comment pattern naturally supports undoable operation. This can be crucial in the system where resolvability of an action is important. Okay, so here are my references. Okay, so that's all for the presentation. So let's move on to the QA session.